The project is a 2-micron holmium laser, which is a novel way of producing 2-micron output that can be used in multiple LiDAR applications. And one of the reasons why we're very interested about it is because it addresses NASA's needs in multiple decadal survey steps. And namely, the first one would be the CO2, atmospheric CO2 measurement, and the second one would be the coherent wind LiDAR measurement. Once we get the funding, the first thing we did is build a model. And this model will tell us the performance of the laser and the limits of the laser. And after we did the calculation, we put together a little breadboard and evaluated and verified the model. And the laser that we built showed us that we can produce a very high rep rate laser up to 10 kilohertz. And we produced up to 8 watts of output. The advantage of having a high rep rate laser is that in an airborne platform or in space platform, when you have high rep rate, you can average much more, and you can also have a bigger coverage. Well, one of the most important attributes of this laser is that it's eye safe. And for example, if we want to use this laser in airports where there are thousands of people, we can operate it without being worried about the eye safety. And this laser, of course, in addition to NASA application, it has a whole bunch of other commercial application. For example, in the aviation, it can detect wake vortex, clear air turbulence. In the medicine area, it can be used for diagnostics or even for healing. And in other science areas, it can produce nonlinear applications where you can have 3 to 10 micron for countermeasure applications. Holmium laser that we're using now has much more efficiency than the previous lasers that we have used. The reason why this happened is because we separated the ions in the thulium between holmium and thulium, and there won't be any energy transfer between them. And as a result, we found the holmium to be much more efficient because the thermal loading is definitely much lower than the holmium thulium system.